Hey everyone, welcome back to my YouTube channel. And today is day 35 of solving daily problems on LeetCode. Let us see what today's problem is. So the problem is to find the first missing positive. It is a hard level problem with the acceptance rate of only 38%. So let us first read this problem and understand the logic behind it. So it says given an unsorted integer array nums, return the smallest positive integer that is not present in nums. You must implement an algorithm that runs in O(n) of time and uses auxiliary space O1. As you can see in example 1, if the given array is 1 to 0, so the smallest positive number in this range which is missing is 0, 1, 2. The elements are 0, 1, 2 and the missing number is 3, the smallest positive integer. Similarly, in example second, you can see that 1 is in the array but 2 is missing. So 2 will be my smallest possible number which is missing from the array. So let us try to understand it. So here you can see that this is the problem. Wait, let me just move it here. Okay, now as you can see that here the sample example I have taken of 120. Okay, and after that the intuition behind this problem is that the problem requires finding the smallest positive integer. It requires to find the smallest positive integer that is not present in an unsorted array of integers. Okay, and the most efficiently we can utilize the fact that answer lies within the range 0 1 n plus 1. Okay, so my answer is within this range. If it is 1 to 4 1 to 4, then it might be possible that the array contains 1 2 3 4, which means all the numbers are present. In this case my answer will be 4 plus 1, which will be equals to 5. So in this case 5 will become the missing number in the range. Okay, so that's why here we are taking n plus 1. Now what we will do, that we will rearrange the elements of array and we can position each positive integer of I at index I minus 1. This means let me create an array here. So let's say this is my array. Okay, and we will consider the example 1, and the array always has a 0 base indexing that we all know. So 0 1 2 and this will become 3. Okay, for this array. Now I will check from 1 to n plus 1. Okay, now what I will do is I will position each positive integer I at index I minus 1. So for this, if my index value is 1, I means 1, then I will position it at 0. Then for 2, it will be at this number, and this will nums I will not equals to I plus 1, which means nums 2 is not equals to 2 plus 3, and 3 is not present in this array. So in that case we will simply return 3 from this. Now we have to iterate through the array and place a positive integer I at index I minus 1 if possible. This ensures that element nums I is equals to nums I plus 1, and if it exists in the array. Now second, what we will do, we will iterate through the array again to find the first index where it is not equal. Then I will return the I plus 1 as the smallest missing positive integer. If my loop runs from 1 to n successfully, in that case I will just return n plus 1, knowing that all the elements in the given range are present. As I can see in this example, all the elements in the given range were present. That's why my answer became 5. Now complexity, as mentioned in the question, is O of n, and extra space we are using is O of 1, which is a constant space. So now let us see how we have done this in code. So this is the code which says that n is the size of array. Now for int I equals to 0, I have run a for loop till n, which is the size of my vector, taking the element here int x equals to nums I. Let's say my array is 1, 2, 3 and 4. My num size will be equals to 4. Okay. Now in this given array, I have added in this given array the elements are 1, 2, 3, 4, and here I have added some comments to understand the logic of this code. Okay. Now if you see, x greater than equals to 1 and x less than equals to 1 is to check if x is in the range of 1 to n or not. We have to stop wherever we get a element which is not equals to I plus 1, x not equals to I plus 1, and at that particular index I have to return the I plus 1 element as the smallest element which is missing in my array. Next, we are also checking for nums x minus I not equals to x, which means we are checking the previous element at the correct at index x minus 1 should be the correct element which is present. Okay. Let's say I am at index number. Okay, let me write. I am at index number 1. Okay. So now from here I will check that if 1, as so here the element should also be equals to 1. This is I'm checking in this condition. So I have added all three conditions in my while loop like this, and after that we are performing a swap operation, because initially the array is not like this. Initially the array might be arranged in a very different order, let's say 2 3 4 1. So in that case we are positioning the elements at correct position. I will swap this element, bring it here, means after performing multiple swap operations I will get the array as result as this. Okay, and this loop will run until these three conditions are true. After that, I have run a for loop to check for int I equals to 0 and I less than n. This whole loop was to arrange the elements in a correct order, and now we are checking here if nums I is equals to I plus 1. In that case, I have to continue, else I have to return I plus 1. This means, let's say my arranged array becomes 1, 2, 3, 4. Okay, so in this array, this is at 0 index, this is at first index, this is at second, and this is at third index. Okay, now I will check if nums I, any num 0 which is equals to 1 is equals to 0 plus 1 or not. So 0 plus 1 be 1 and this condition will be true. So here this condition will be true. So I will continue and I will move my pointer ahead. Okay. Now again I will check nums I, which is equals to 2, and it should be equals to I plus 1. So my I value is 1 and I will plus 1, which will become 2. So this condition is also true. And after checking for all the numbers, it will reach here, and here the condition will become false. After that means this loop will end, and my value will increase, and at last I will return n plus 1. N plus 1 because all the elements in the given range are present. That's why I'm returning from here n plus 1, which is storing the value of 5 in it, and 5 will become my answer for this given array. So let us try to code this problem here. Now first was I have taken the size of my array, which will be equals to nums.size. Now next I'm checking next what we have to do is, after calculating the size of array, we will run a for loop to check for the to arrange the elements. So for int I equals to 0, I less than n, and we will increment the value of I. Let's say int x, and x is the current element which I am taking from my array. Now while first we will check that x should be greater than equals to 1, and x should be less than equals to n. So here in this case we will not use 0, we will not fill 0 because 0 is less than 1. Okay, now here the other conditions were that x should not be equal, if it's not equals to n minus 1, n plus 1. In that case I will check for the elements, and now after checking for the third condition, my fourth condition here was to check the previous element whether it's equal or not. Okay, so these are my four conditions which I'm checking here. Now I have to perform the swap operation in order to arrange my array in particular order, in increasing order, and it will be nums I. After swapping the element, I will change the current element as x equals to nums I. After performing these operations, I will again run a for loop to check for elements which are missing from the array. Now inside this for condition, we will check if nums I is equals to I plus 1. In that case, I have to continue. Otherwise, just return from here I plus 1. And at last, if all the conditions are true, it means number in 1 to n range are present. So I have to return n plus 1 in that case. Okay. Now just we'll run this code. It is accepted, and let's just submit this. So we have solved today's problem, and it was a hard level question of arrays, but we have solved it, and this code is very minimal. For a hard level problem, you have to write a bunch of lines to be the code should to be executed correctly. But here you can see that it is quite easy to understand. That first, we here in this loop we are arranging elements in ascending order. After that, what we have done is here we are checking for conditions, all conditions to be true. Then after that, checking for checking current value with index, and after that returning n plus 1 as all other elements are present in array in the range. Okay, so I hope the solution is clear to you. Please like this video, comment on it, subscribe to my channel, press the bell icon to get daily notifications about videos I'm posting, and thanks for watching. I will see you in the next video.